In chemistry, they feel there's more than 20 million known compounds, and that's a huge number. But most of them are based, of course, on carbon and oxygen and nitrogen and hydrogen, things like that, the organic compounds. So even though I love my metals in the last chapter we looked at, chapter 19, most of the chemicals, of course, are based on organic chemistry. And carbon is amazing, all right? Carbon is really cool in the kind of things it does. And it's not just carbon, it's hydrogen and oxygen and stuff like that. But if you look at the 4 different structures we're seeing there, this is just some representations of what carbon can do. And some of them we've seen before in similar circumstances, some of them we have not. Carbon is amazingly versatile, and we'll see how carbon can bond to itself in a variety of ways and make a variety of different compounds that probably are new to you or maybe you haven't expected before. So in organic chemistry, the year-long class, there's basically 2 parts to it. And the first is nomenclature, being able to name the molecules correctly. And that's what we're going to focus on this section, all right, in this little section of Chem 223. We won't be able to do justice to, of course, the complete year, and we're not going to look at all the details of nomenclature either. But we'll give a good examples and see kind of how this rolls together so that if and when you take the actual class, you'll be good to go. But the majority of organic chemistry is on reactivity, and reactivity, of course, is how you make the molecules that you're talking about and also what you do with the molecules once you've made them. And it's a huge area. I'm going to give you a couple of examples just for fun, but again, I won't quiz or ask you any questions on anything to do with reactivity. We're going to focus on nomenclature. So anyway, it's a cool chapter. Honestly, organic chemistry is where I really learned to love chemistry. I mean, I'd always liked it before, but in organic chemistry, wow, it hit hard. So even though my weird start to it that I want to have you avoid at all possible, I really did learn to love chemistry by looking at organic chemistry. So let's check this out, see what it has to offer, and see if I can entice you further into the world of chemistry. From the Lewis structures and Vesper geometry studies we did back in Chemistry 221, carbon can only make 4 bonds, and that's a hard limit. All right, carbon cannot make 5 bonds, stuff like that. Now, sometimes it can do strange things and make different ones, but it's 4 bonds is kind of the rule. Now, on the right-hand side are different ways to write carbon. Now, remember that the actual carbons are usually going to be tetrahedral, which is 109 degrees. So sometimes, like in the top there, I will write just 4 carbons in a row. But really, in the real world, those carbons with single bonds would all be tetrahedral, and they would be about 109 degrees apart from each other. And likewise, if I draw the next one with 3 carbons in a line and 1 carbon down, that would be something like the one below. And then you can have different combinations like this one and this one, all these kind of things. So despite the limitations of our drawings, you have to remember in the back of your mind, this is still 109 degrees, tetrahedral, sp3 hybridized, if you remember all those terms from Chem 221, no worries. So these skeleton drawings are very common, or line drawings, all right? They're just showing the carbon atoms. They don't necessarily show all the other atoms. Now let's assume that those 4 atoms there on the top level, they're surrounded with hydrogen, no problem. So the actual structural formula would look like that, and that shows all the hydrogens and stuff. However, notice the carbons are all in a row. But maybe you're using Microsoft Word and you can't make fancy lines up and down, then you might want to make a structure like that, sometimes called a condensed structure. However, in organic chemistry, hydrogen is so prevalent, often the hydrogens are completely omitted. So this next one right there is a true line structure. It's called a carbon skeleton formula, and it only shows the carbons. It doesn't show the hydrogens. And you, as the hip chemist, need to know that every one of those vertices is a carbon, and carbon has to have 4 bonds. So if there's nothing else showing, then there's going to be bonds to hydrogen. So for example, on the very end, on the left-hand side, that little vertice, that would be a carbon. It would have another bond to the next vertice, to the next carbon, but that carbon with only 1 bond would have 3 hydrogens around it, etc., etc., etc. Now, ball and stick stick will show the tetrahedral nature of all the atoms really well. Space-filling models on the far right will show what the electrons are probably more like because they actually mesh together. They don't have nice little single bonds. Anyway, welcome to the world of organic chemistry. There's many different ways to show them. Now, those carbon skeleton formulas in the middle will be important. A lot of times this is how organic chemists write them. Hydrogen is just all over the place, so if you can ignore the hydrogen, it's easier. That's why those skeleton formulas will show up a lot. So kind of familiarize yourself with these. And by the way, you can have double bonds and you can have triple bonds, no problem. Notice in the skeleton formulas, the double bonds are kind of like straight across, triple bonds literally 180 degrees from each other. All the things we learned in the Lewis structures / Vesper area still applies. We're just thinking about organic chemicals now. So to build an organic chemical, you need to know about the alkyl groups. And alkyl groups are literally the building blocks of the organic molecules. And these names that the alkyl groups are going to be referred to are going to resonate with some of the families of organic chemicals we'll look at here in a little bit. All right, so the alkyl groups aren't compounds themselves, but you can combine an alkyl group with hydrogen, chlorine, another alkyl group, whatever, to make a molecule. The simplest of the alkyl groups is called methyl. Methyl has a single carbon that's in a tetrahedral environment. It's sp3. So you can see there from the methyl group that carbon has 3 hydrogens, but carbon needs to have 4 bonds. So there's like one spot on the carbon left over to bond to something else. So the methyl group is not an organic chemical, but it's a building block of the other things we're going to see. So while methyl is associated with 1 carbon, ethyl is associated with 2 carbons. So if you put another tetrahedral carbon on that CH3, now the carbon on the far left has 3 hydrogens and a bond to carbon. But the bond on the right now, which has a bond to carbon by the way, has 2 hydrogens and 1 more spot. So it has another place that it can make a connection to. So again, ethyl and methyl, they are not compounds, but they're the building blocks of compounds we're going to see. So 1 carbon is methyl, 2 carbons is ethyl, 3 carbons in a row becomes propyl. So you can see there's 3 carbons in a row like that. No problem. You're just adding another tetrahedral sp3 on the end. And you can have butyl, and you can have all kinds of them. So methyl is 1, ethyl is 2, propyl is 3, butyl is 4. Pentyl would be 5 carbons in a row, again all tetrahedral sp3. Hexyl would be 6, heptyl 7, octyl 8, etc., etc. And sometimes people will use a capital R to represent a generic alkyl group. We'll talk about this more in a little bit. And again, none of these alkyl groups are compounds unto themselves, but they're the building blocks of it. So we'll see how they can be built up. Now down here on the bottom, I have a link to the Organic Chemistry Nomenclature Guide, which is in your companion and online. It has a lot of these families as well as the alkyl groups, and you can see how the alkyl groups will be helpful. So I encourage you to check that out in this section. Alkyl groups are not compounds, they are sp3 hybridized carbons, and they're missing 1 component. So again, you're not going to have a compound out of them, but you will be able to build them to make cool compounds.